circle and the tangent equation. Now, if a circle is given to us with center as, let's say, the center to the circle is a point C, and if I join this center to point A, at which there is a tangent also passing through A, so I know that CA is the radius of the circle, and we know the identity and the property that the radius of a circle is always perpendicular to the tangent. So this is one property that we should be knowing very well, that the radius and tangent, they are always perpendicular to each other. So radius AT is the tangent, so I can say that radius and tangent at A, they shall be making 90 degrees with respect to each other. So this is a very important property for us to know before starting to form an equation of a tangent. So if the two are perpendicular to each other, so I can very easily say that the radius or the line AC can be having the gradient which is let's say m1, and the tangent AT will also be having the gradient which is m2, and we know very well that the product of two perpendiculars m1 and m2 will be equal to a -1. So these are the two very main identities that we shall be applying to form the equation of a tangent. So let's do a question. Question says, determine the equation of the tangent to the circle center C with equation x square plus y square minus 2xy minus 5. So we have the circle equation, which is x square plus y square minus 2x minus y. Center is a C, and there is a point A which is 2 comma 5. So equation of the tangent to the circle at the point 2 comma 5. So I have drawn this tangent at point A with coordinates 2 and 5 here. Coordinates of A 2 comma 5, I have drawn the tangent. The center is not known to us, but we know that the equation of the circle is x square plus y square minus 2x minus 4y minus 5 is equal to 0. So unless and until we don't know the center, obviously we cannot have the radius, and also we cannot have the gradient value as well. So these are the two things that we talked about when we have a tangent and when we have a tangent to the circle. So how to find the center? Rearrange the equation so that you can say it's an x square minus 2x, and then leaving some space, I'm saying it's a plus y square minus 4y, and this will be equal to 5. I've taken the 5 on the right side. I need it in the form x minus a the whole square, which is a perfect square, which represents the identity as a minus b the whole square. To do that, I will be using my completing square method, and we know that for completing square method, we have to divide the coefficient of x by 2. So if I divide the coefficient of x, which is a 2 in this case, by 2, I'm getting a 1. So I should be adding and subtracting a 1 the whole square to the equation. So for this x, to bring it to the algebraic identity, I'll say it's plus 1 the whole square and also minus 1 the whole square. In the same manner, for y, the coefficient of y is a 4. I'll divide 4 by 2, which will give me a 2, and I will be adding and subtracting 2 the whole square to the equation. So it's plus 2 the whole square and minus 2 the whole square as well. So from here, just doing completing square method, the first 3 terms, as discussed earlier, in quadratics, I should say that they should be representing x minus 1 the whole square, plus we have to be taking the sign of the coefficient of y. So it's y minus 2 the whole square. Negative 1 the whole square will be a negative 1. Negative 2 the whole square will be a negative 4, and this equals 5. Or I can say that this is x minus 1 the whole square plus y minus 2 the whole square. This is equals to a 5 plus 1 and a plus 4. Or I can say that this is x minus 1 the whole square plus y minus 2 the whole square, and radius square will be equal to a 10, meaning the radius then is under root 10. That's very much clear. So now I have brought the equation to the form x minus a the whole square plus y minus b the whole square. So from here I know the center coordinates. The center coordinates are going to be 1 and a 2, and my radius is going to be under root 10. I have the radius, which is under root 10. I have the center coordinates, which are 1 comma 2 here. Right, so I need to have the equation of the tangent, and to have the equation of a tangent, this being a straight line, I should be having the gradient, and for that I can say that the gradient of tangent is actually equal to negative inverse of the gradient of AC. I have the coordinates of A, 2 and 5. A, it was 2 and 5. Center was just found as 1 comma 2. Therefore, the gradient for AC will be equal to 5 minus 2 divided by 2 minus 1, and this would give me a 3 divided by 1. Therefore, the gradient of the tangent AT will be equal to a negative 1 by 3. So equation is y equals equation of a straight line mx plus c. Y equals the gradient, which is negative 1 by 3x plus c. Now how to find the c value, or how to find the y-intercept for the straight line? We have a point on the tangent, and that point is 2 comma 5. So this 2 comma 5, which is a in this case, that can be substitute for x and y, meaning I can say it's a 5, which is equals to negative 1 by 3 into 2 plus c, or I can say it's a 5 plus 2 by 3, which is equals to c, and then the c value becomes a 17 divided by 3 here, meaning this tangent shall be having the equation, which is negative 1 by 3x plus c, which is a 17 by 3, or solving by taking the LCM, I can say it's a 3y, which is equals to negative x plus 17, or further I can say it's a 3y plus x minus 17. This is equals to 0. So this is going to be the equation of the tangent. That's going to be my solution for the given question. So the second question says AB is the diameter of the circle. Let's start underlining the keywords. AB is the diameter of the circle, where we know that the radius is half of the diameter. A is 2 comma 6 and B is 8 comma 2. So these are the 2 points present on the circumference of the circle. The tangent to the circle, now there is a tangent to the circle at B, which is passing through B, and this meets the x-axis at P and the y-axis at Q. So we know for x-axis, the y-coordinate is a 0. For x-axis, it's the y-coordinate, which is a 0. So I can say that it has coordinate as x comma b, and this is the point P, which lies on the x-axis, and Q lies on the y-axis. Q is on the y-axis, and on the y-axis we know that our x is a 0. Therefore here it should be having the coordinates as 0 comma y. So we need to find the coordinates of P and Q. So the objective is to get the coordinates of P and Q. So if I make the circle here, so AB is the diameter of the circle, A and B. So I've made the diameter. Let's say the center lies here, and the center here is point C. And the tangent to the circle at B, I've made a tangent to the circle which is meeting the x-axis at P. So this is the x-axis at P with coordinate of y as a 0, and it has the y coordinate at Q. The coordinate of x is a 0, so it will be having a y coordinate here. So we are supposed to get the coordinates of P and Q. So unless and until we don't have the tangent equation, we cannot have the coordinate of P and Q. So how to make the tangent equation? I do have for equation of tangent. For equation of tangent, I do have the x and y coordinate as it's passing through B with coordinates 8, 2. The other thing that I need is the gradient value. So with respect to that, I know that the radius or the diameter, they are perpendicular to each other. Therefore, the gradient of AB is going to be the negative inverse of the gradient of the tangent. Now, to find the gradient of AB, I will say it's the y coordinate of A minus the y coordinate of B, which is a 2. So 6 minus 2 divided by the x coordinate of A minus the y coordinate of the x coordinate of B, which is an 8. So this becomes a 4 divided by negative 6, or I can say that the gradient of AB is a negative 2 by 3. So therefore, tangent being perpendicular, the gradient of the tangent, let's say this tangent is PQ or whatever, P, PBQ or whatever you want to call it, the gradient of tangent will be negative inverse. So therefore, this becomes a 3 by 2 here. I have the coordinate 8, 2 passing through the tangent. So I'll simply say it's y, which is equals to mx plus c, and also I can use the equation, the general equation, which said that equation of a straight line was y minus y1 equals gradient times x minus x1. I do have y1 and x1, which is 8 and 2. Therefore, this is y minus 2, which is equals to 3 by 2, and x minus 8. So I will be getting the equation of the tangent, or in other words, I can say this actually is the tangent equation. I don't want to solve it further just to save time, because I know my question asked me to get the coordinates of P and Q. For P, I know it should be x comma 0. My y is a 0. So I'm just going to substitute y as 0, so that I'm left only with negative 2, which equals 3 by 2 and x minus 8. Or further, I can say it's a negative 4 by 3, which is equals to x minus 8, or x will be equal to negative 4 by 3 and a plus 8, and this would give me a negative 20 by 3 here. Positive 20 by 3 here. So P has coordinates, which is 20 by 3 and a 0. So to find Q, I know my x is a 0, there is a y. The gradient remains the same, which is 3 by 2. So the tangent was passing through the point B with coordinates 8, 2. So it's y minus y1, which is a 2, is equals to 3 by 2, and x minus x1, which is an 8. Substituting x as 0, I will be left with y minus 2 is equals to 3 by 2 times a negative 8, or I can say it's y minus 2, which is equals to negative 12, or I can say that y value here is going to be a negative 10, meaning Q shall be having the coordinate as 0 and negative 10 here. So the two values, they very well satisfied the diagram that we made. Q was below the origin Q was below the origin, so 0 and -10, yes, that is the coordinate, and P shall be having the coordinate which we found as 20 by 3 comma 0. So this also looks perfect here. Therefore, just write the answer. The coordinate of P is a 20 by 3 comma 0, and Q will be equal to 0 comma -10. This is what the coordinates of P and Q for the required tangent shall be. So the points P, Q and R have coordinates 0, 2. So 0, 2, P 0, 2, let's call this point P. Q is 4, 0, lying on the x-axis, and we have another point 8, 8, which is, let's say, Q. So show that PQR is a right angled triangle, meaning at Q it should be having a right angled triangle, and hence find, we have to show that it's a right angled triangle, and then hence find the equation of the circle again. So equation of the circle, for that two things are necessary. One is the center point, and the other is the radius of the circle. So if I just start marking my coordinates, P is 0, 2, meaning it lies on the y-axis. Therefore, P lies here with coordinates 0, 2. The y-intercept is a 2. Q is 4, 0. Therefore, Q is here with coordinates 4, 0, lying on the x-axis. And there is a point 8, 8 as well, which is point R. So they have said that PQR is a right angle triangle, and we are dealing with a circle. So if we go back to the concept of circle geometry, we know that in circles, if we are given a circle, then in circle against the diameter, we always have a semicircle which should be making 90 degrees with respect to the circumference. So this is called the semicircle property of the circle. Semicircle property of the circle, which says that there is a right angle, there is a right triangle or a right angle against the diameter. So we have the right angle against the diameter. So that means this should be passing through the center, and we can say that AB is the diameter here. So obviously AO then will be the center, will be the radius of the circle. So here again, if they are saying that PQR should be a right angle triangle, then this means that P and R, they should be making the diameter of the circle. That's only possible if P and R, they are making diameter of the circle, because against the diameter we will always have a right angled triangle. So we have made the diagram. They haven't given us the hint. It's for us to know that for a right angle triangle in a circle, it has to be against the diameter. So here we are assuming that P and R, they are making the diameter to the circle, R with coordinates 8, 8 here. So we have to show that PQR is a right angle triangle, and for that again we have to take help of Pythagoras theorem, and we know that for Pythagoras theorem it's hypotenuse the whole square that equals to perpendicular the whole square and base the whole square. That means I should be having PQ as well as QR as well as PR. So P is with coordinates 0, 2. Q is with coordinates 4, 0. So to find the distance of PQ, I should say that this is going to be under root 0 minus 4 the whole square plus 2 minus 0 the whole square, and this PQ then is equal to under root 16 and a plus 2 square, which gives me a 4, and this value is a 20 here. So PQ is going to be under root 20. In the same manner, find RQ. So R with coordinates 8, Q with coordinate x coordinate as a 4, it's the whole square, plus 8 minus 0 the whole square, or I can say that my answer is going to be 8 minus 4, which is a 4, and 4 the whole square, that would give me a 16. So it's 8 minus 4 the whole square, that is 4 the whole square, giving me a 16 and a 64 here. That should be equal to under root 6 and 4, 10, and 6, 7, 8 under root 80. So we have PQ, we have RQ, meaning we have the base, we have the perpendicular. PQ is under root 20 and RQ is under root 80. So to find PR, it should be P with coordinates 0, 2, R with coordinates 8, 8. If I find PR, then this is going to be under root 8 minus 0 the whole square plus 8 minus 2 the whole square, and this would give me under root 64 plus 36, and that should be equal to a under root 100, and that equals a 10. So applying the Pythagoras theorem, we already discussed it should be equal to h square, that equals a p square plus b square. So substituting the values, I should say it's a 10 the whole square, which is equals to under root 20 the whole square plus under root 80 the whole square. The radical and square, they get cancelled. I'll be left with 100, that equals to a 20 plus 80, and this is shown that 100 is equals to 100. Therefore, we can say that PQR is a right angle, against PR. So we have shown that it's a right angle triangle against PR. Second part says, hence find the equation of the circle that passes through P, Q, and R. So to get the equation of the circle, it's the center and the radius that should be remaining. To find the radius, I already have PR, and PR was equal to a 10. So PR was equal to a 10. So I can say that the radius in this case should be equal to a 5 and a 5. I have the radius. So the other thing that is left is to get the center point, or the midpoint of P and R. So just get the midpoint of P and R. I can say that P is 0, 2, R was 8, 8. So the center is going to be the midpoint of P and R. So the midpoint then is going to be x1 plus x2, meaning 8 plus 0 divided by 2, and 8 plus 2 divided by 2. That would give me the midpoint as 8 by 2, which gives me a 4, and 8 plus 2, that is a 10. 10 divided by 2, that gives me a that gives me a 5. Therefore, I have the midpoint, which is 4, 5. So I have the radius and the center as 4, 5, and the radius as a 5. So the equation of the circle is very easy to define. It should be x minus 4 the whole square plus y minus 5 the whole square, and this is equals to 5 square. Or I can say this is x minus 4 the whole square plus y minus 5 the whole square, that equals a 25. So this should be the answer to the second part also. So this is all about circles with respect to coordinate geometry. Now the only topic left is to do the past papers. So in the next video, we shall be doing past paper questions.